I'm Anil Kumar, and in this video we'll try to understand indeterminate difference and application of Lee-Hospital's rule to find the limit. The question is, find limit when x approaches 0 of 1 over x minus cosecant x. Now if you analyze, as x approaches 0, 1 over x approaches infinity, right? 1 over 0. Now how about cosecant x? Cosecant x is basically 1 over sine x, right? So as x approaches 0, 1 over sine x approaches 1 over 0, that is, it approaches infinity, right? So in this particular case, we have infinity minus infinity. That is what we call indeterminate difference, right? We are not very sure whether the result is going to be whether this will lead to positive infinity or it will lead to negative infinity or somewhere in between. So that is what we say indeterminate difference, right? Now Lee-Hospital's rule can be applied to find the limit of such functions. Now let us factor or kind of combine them. I'll rewrite this function as limit x approaches 0 of 1 over x minus cosecant x as 1 over sine x, right? Now we'll take common denominator, simplify this a bit. So the common denominator is x sine x. Here we get sine x minus x. At this stage, you can very clearly see that as x approaches 0, what happens? Let me rewrite here. If I write sine 0, so I get sine 0 minus 0 in the numerator, and I get 0 times sine 0 in the denominator. Sine 0 is 0, as you know. 0 minus 0 is 0, so we get 0 over 0. Now that is the fundamental rule for indeterminate form where Lee-Hospital's rule can be always applied, right? So we'll apply the Lee-Hospital's rule, which says that the limit of quotient of these functions is same as limit of quotient of their derivatives, right? So now let us write down the derivatives of the numerator and the denominator. So derivative of sine x is cosine x. Let me write down this as cos x minus 1, that is the derivative of x, and we'll do product rule for the denominator. X times sine x, derivative of x is 1, so we get sine x, plus x times derivative of sine x, which is cos x, right? So that is when we apply the Lee-Hospital's rule. So at this stage we have applied, we found the derivative. Now if you substitute 0, what is cos of 0? Cos of 0 is 1, right? So at this stage also we see that cos of 0 minus 1 over, we have sine 0 plus 0 times cos of 0. Now that is 1 minus 1. Sine 0 is 0. Plus 0 times anything is 0. So we get 0 over 0. That means we can again apply the Lee-Hospital's rule, right? So let's again differentiate both numerator and denominator. It is important to check. So it is, let me write down here. Important to check, right, before you apply the rule. So make this a point. Every time when you're applying this rule, you have to check if you have the indeterminate form or not, right? This indeterminate form, which is 0 over 0 or infinity over infinity, right? Derivative of cos x is minus sine x. So we get minus sine x in the numerator. Derivative of 1 is 0. In the denominator, sine x derivative is cos x. So we get cos x. Here we'll apply the product rule. X derivative is 1, so we get cos x plus x times derivative of cos x, which is minus sine x. So let me write down this as minus x sine x. Is it okay? So that is what you get your derivative. Now at this stage, you can again substitute 0 and see the result. So what do you get? You get minus sine 0 divided by cos of 0 minus cos of 0 minus x times, this is plus, minus x times, which is 0, times sine 0, right? So minus sine 0 is 0, so you get 0 over cos 0 is 1, so you get 1 plus 1 minus 0, which is 0 over 2, and that is indeed equal to 0, right? So the limit of this function is 0. So we get our answer as limit x approaches 0 for 1 over x minus cosecant x equals to 0, right? So I hope the steps are absolutely clear. I've purposely gone slow and I've explained each and every step here so that you understand why and when to apply L'Hospital's rule. It is important to check at every stage whether the form is indeterminate or not. If it is indeterminate, you could differentiate numerator and denominator, that is, apply the L'Hospital's rule and get the result. I'm Anil Kumar and I hope that helps. You can always share and subscribe my videos. Thank you and all the best.